Hello viewers, Wardaruna taking you through the story for O-level math contest practice. And this video we are going to go through the topic of factorials and combinations. So this video is suitable for students in both Senior 1 and Senior 2 with passion of one day participating in the National Math Contest and thereafter Math Olympiads. So I think realize that the days have been reduced by 1. Previously there were topics we were running up to day 6. So what we did, we combined the video of day 3 and day 4 into one, because day 3 was factorials and day 4 was combinations. So we combined them into one video so that the days can reduce and we stop a little earlier so that students can prepare to go back for the term. So today we have to look at factorials and combinations. So let's start with factorials. So a factorial is a convenient way of expressing the answer to any natural number multiplied together with all its preceding natural numbers. So natural number, you keep on multiplying. For example, if I have 5, preceding natural numbers are 4, 3, 2, and 1. So what this statement means, you multiply all of them. So that's what factorial means. And we use a symbol, this exclamation mark is what we use to denote factorial. Therefore, if I write this 6 exclamation mark, it means 6 factorial in this topic. So that means that when I write 6 factorial, like we said here, that all the natural numbers, preceding natural numbers are multiplied. So if I have 6, I'll begin with 6, reduced by 1 to get 5, reduced by 1 to get 4, reduced by 1 to get 3, reduced by 1 to get 2, reduced by 1 to get 1. So stop here, because if I reduce by 1, I'll get 0, and we know that any number multiplied by 0 is 0, so it will be meaningless. So you have to stop at 1 based on this word, natural numbers. And when I multiply everything, I'll come up with 72. So when they ask for the value of 6 factorial, they want you to go through this and at the end get 720. Let's call that expression 1. So from this expression 1, it means that we multiply all whole numbers from our chosen number down up to 1. All whole numbers down up to 1. I think you realize we stopped at 1. So that's what factorial basically is all about. So there's some important note here, that if you multiply down but you don't reach 1, you must put a factorial on that number you have stopped at. For example, if I say 6 factorial is equal to 6 times 5 times 4, and I stop at 4, it implies that I should put a factorial at that 4. And that rule is very, very important, as we shall see in the examples. For example, 6 factorial is equal to 6 times 5 times 4 factorial. Because this is not 1, that's why I add there a factorial. So why is it so? It is because 4 factorial is 4 times 3 times 2 times 1. And when you substitute for this in equation 2, in expression 2, we'll come up with this, which is the actual factorial of 6. So like I said, this concept is used to simplify factorials without using tables or calculators, as you can see below. So example 1 says, without using tables or calculators, simplify the following. So part A, 8 factorial over 6 factorial. So shall come and say that 8 factorial is the same as 8 times 7 times 6 factorial. Now you're putting a factorial here because if the factorial is not there, it should go up to 1. But if it doesn't stop at 1, we have to put a factorial. Now, of the numbers, natural numbers, why did we choose to stop at 6 factorial? It is because in the denominator we have already 6 factorial, therefore these two can easily cancel out. And then when they cancel out, remain with 8 times 7, which is 53. And that's what they wanted. Then part B, this one is, when you see here 8 factorial, 3 factorial, it means that in between there is a multiplication sign. Then from there, here we have 8 factorial and here 9 factorial. So it is 9 which shall reduce, which shall expand. So it will become 9 times 8 factorial. And the reason why we stop at 8 is that this can cancel with this. So for 3 factorial, expand up to 1, 3 times 2 times 1. So 3 times 2 is 6, and 9 is there, reduced to come up with 2 over 3, and that's what they wanted. What about 5 factorial, 7 factorial over 3 factorial, 6 factorial? So like I said, in between here there is a multiplication sign. Then we begin. Here down we have 6, so we have 3 and 6. Up we have 5 and 7, meaning that this 7 will be reduced up to 6. You see this? 7 times 6 factorial to cater for this, so they cancel out. Then this 5 will be reduced up to 3 to cater for this, so they cancel out. And when that happens, we are going to remain with, so this will go with this will go with this. So remain with 5 times 4 times 7. So 5 times 4 is 20. 20 times 7 is 140. And that's what they wanted. Then part D, there is something also. Here is 22. Here there is 21 factorial and here 20 factorial. So this, first of all, there's a subtraction sign, meaning that you have to first reduce this one to be similar to this, then we factor out what is common. So therefore 21 factorial is the same as 21 times 20 factorial. Then this one remains. Then also here 22 factorial becomes 22 times 21 times 20 factorial. So when we deal with the denominator first, 20 factorial will be common. So here I remain with 21 and here I remain with 1. Then I realize that this and this can cancel. So I'll remain with 22 over times 21, everything divided by 20. When I reduce by 2 here, it gives me 11, which is here, and by 2 here, it gives me 10. Then when I apply the numerator, I'll come up with 231, down there is 10, so it will become 23.1. Then part E was about simplifying. Now the simplifying, so first of all, down here we have n plus 2 and n minus 1. Then here we have n plus 1 and n minus 2, meaning that we are going to, this one will be reduced to be similar to n plus 1, and this one will also be reduced to be similar to n minus 2. So this becomes n plus 2 times n plus 1. Now, why are we saying plus 1? It is because, remember we said it reduces by 1. So if I have n plus 2, then I say minus 1, I remain with n plus 1, which is this. Same applies to this, n minus 1. So n minus 1. When you reduce by 1, it becomes this, which is minus 2, as you can see it here. So the reason why we stop at that is because this is able to cancel with that, and this is able to cancel with this. So we're going to remain with that. and that's what they wanted. Then example 2 says solve for x when they give you x plus 2 factorial over x minus 1 factorial equal to 60. So still we are going to do the same. We are going to expand the numerator to be similar to this. So first is x plus 2 minus 1 gives x plus 1 minus 1 gives x minus 1 gives x minus 1, which is here. So these two will cancel and you remain with that. So the only product of three numbers which are consecutive and gives 60 is 5 times 4 times 3. That means that this will be for this, this will be for this, and this will be for this. Therefore, x is equal to 3. Now we shall go to double factorial. So in factorial or normal factorial, numbers were reducing by 1. But when they talk about double factorial, it means that numbers keep reducing by 2. For example, if I have 11 double factorial to become 11, then minus 2 to give you 9, minus 2 to give 7, minus 2 to give 5, minus 2 to give 3, minus 2 to give 1. That is when it is odd. When it is even, let's see what happens. 12 minus 2 to give 10, minus 2 to give 8, minus 2 to give 6, minus 2 to give 4, minus 2 to give 2. So if you again say this minus 2, you get 0, so you can't go to 0. Therefore, you stop at 2. So that means that for odd numbers, factorials keep reducing up to 1, while for even numbers, they keep reducing up to 2. With that, you can go through these questions that using tables or calculator, evaluate or simplify the following. So let's start with Roman 1. Roman 1 has that, so we shall reduce. So this one 10 becomes 10 times 9 times 8 factorial. We stop at 8 because of this. Then 11 becomes 11 times 9 double factorial, and we stop at 9 because of that. Then we simplify. This goes with that, this goes with that. So remain with 10, 9, 11. So 9 times 11 gives you 99, 99 times 10 gives you 990. Then part B, they want the square root of that. So first of all, we are going to first expand each term. So 3 factorial is 3 times 2 times 1, which is 6. So now for 3 factorial, in brackets factorial, it means where there is 3 factorial, I'll replace it with 6. That's why I see at 6 and this factorial. So 6 factorial already so that it is equal to 720. Then the double factorial, it will be 3 times 1, which is 3. Therefore, the square root of that is equal to 720. You substitute times 3 times 6, which gives you that, and that's what they wanted. So why do we study factorials? So the main reason why we study factorials is about to help us in arranging distinct items. So factorials are used to determine the number of ways of arranging n different items or objects in order. So suppose we wish to find how many 4-digit numbers there are whose digits are different prime numbers. So there we know that prime numbers, they are 4 digits, 2, 3, 5, 7. So the question wants you to arrange 4-digit numbers using these ones. So how many ways can you rearrange these 4 digits? If you don't have the knowledge of factorial, you'll have to go through the long way by making a long list. So let's start. So this is the list you can make So those are the 6. Then, but they are not, that's not all. There are others up to 12, but that's not all. There are others also. That's not all. There are others also. So I think you realize that this making such a list manually will be so hectic and disturbing. It needs too much patience. And it is for that reason that the knowledge we learn factorials, because the factorials that can help us, as we are going to see in the next slide. So as what I've said, this can be tedious when the objects to arrange become bigger. So how do we use the knowledge of factorials? One, you count how many items do you want to arrange. So in this case, there are 4 digits. So you'll just simply say 4 factorial. And by now we know that 4 factorial is 4 times 3 times 2 times 1, which is 24 ways. So the number of ways I've got here by the knowledge of factorials is similar to this one you got. Because when you count all this, you end up with 24 ways. So factorial is there to make life a little easier. And you can also use the calculator. How do you use the calculator? To use the calculator, factorial symbol is, well, let's start with this one. Factorial symbol is there, but if you look at it, it is in yellow. So because it is in yellow, to get it, you're going to first press Shift, followed by this button. When you do that, the factorial symbol will come here. Therefore, if I want to get 4 factorial, I'm going to first press the button of 4. Then I'll press Shift. Then I press this. The symbol will come. Then I press equal to get the answer. If you have such calculators, you can try that. So applies to this one. Press the button of 4. Press the button of Shift. Press this button. And then equal to. If you have searched to the same procedure, press the button of 4. Press the button of Shift. And press this button. Then an equal sign. The answer will come. So an example is, how many ways can we arrange 12 different books on a shelf? So there are 12, and if you want to go through manually, it will become tedious. So the best thing is to remember the knowledge of factorial, and you say that the number of ways will be 12 factorial, which is this. So I think realize making a list of these, millions of this, it becomes tedious. So it's for that reason that factorials are there. So like I've told you, you can get it by pressing the calculator. Actually, this was for this part. So now we shall go to combinations, stroke selections. So a combination is a selection of objects considered without regard of their order. Remember, for factorial, we wanted arrangement, so the order mattered. But here we want selecting, so the order doesn't matter. So sometimes the problem requires us to make a selection of objects without regard to order. In such a case, a change in order does not yield any new selection. For example, in choosing a committee of 3, John, James, and Jane is the same committee as Jane, James, and John. So they are still the same committee because we have selected the same people. So, and that's what permutation is all about. They don't mind the order. So suppose we wish to find the total number of ways of selecting 3 students from a list of 5 students, namely Anne, Betty, Kate, Dan, and Eve. How can this be done? If you want to do it manually, it will become hectic. But let's try it and we see. So manually, we have that picking that selection, 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 and selection. But that's not all. We still have also this selection. So in total, there are 10 ways of selecting 3 students from a group of 5. But that it may be hectic if the number becomes bigger. So what do? You need to have the knowledge of what we call combinations. So the number of combinations of n different items taking r at a time will be given by that. So we pronounce this as n combination r. And this is the expansion for that combination. N factorial divided by n minus r in brackets factorial multiplied by r factorial. We shall see how it is used. So use this when they tell you without using a calculator. So that means that for the above example, if you have the knowledge of combinations, you would simply say that the total there are 5. So you put 5 here. Then you are picking how many at a time? 3. So you put 3 here to give you 5 combination 3. So here, if I choose not to use a calculator, I'll expand. So this is n, then n minus r is that, then times r factorial. So 5 minus 3 is 2 factorial. So now I'm going to simply expand 5 until I reach 3 factorial. So 5 times 4 times 3 factorial, and the reason is that this can cancel. So I remain with 5 times 4, then here 2 times 1. This is 20, this is 2 to give you 10 ways. I think that's what we got when you did it manually. So the knowledge of combination is there to make life easier. So you can also use the calculator to get that combination by pressing 5 shift division 3 equal to. So this is what will appear on the screen. So if you have this, it depends on the calculators you have. Now what I've written is for this and this. So let's start with that. You're going to press, if you have any of this, you're going to press 5. Then you realize that combination is in yellow. So to get it, you are going to press shift, then this division sign. So the C will come, then you press 3. And after that you press equal to, and answer will come. Same applies to this. 5 shift division sign 3 equal to. But for this one, this first calculator, there's something funny. You realize that the n combination r is in white, meaning you don't need to press shift. What you do, just go and press 5, then this button, then 3, and then equal to. You still get the same answer. So with that, we are going to go through some of the questions first. So one says, in how many ways can you choose or select 3 pool balls from the 16 pool balls on a table? So here there's total is 16, meaning it will be 16 combination 3. And when you use the calculator, you come up with 560 ways. As simple as that. Then question 2, a competition consists of selecting 3 suitable gifts from a list of 20 possible wedding presents. In how many ways can this be done? So the total is 20, so it will be 20 combination 3 to give you that. Then question 3, in how many ways 2 bats and 3 balls can 2 bats and 3 balls be selected from 5 bats and 7 balls? So now here we have 2 items. Let's start with the one for bats. Number of ways of selecting 2 bats from 5 is 5 combination 2, which is 10. Then we shall go to balls. Number of ways of selecting 3 balls from 7 is 7 combination 3, which is 35. using a calculator. So therefore the total number of ways is got by multiplying, which is 350. That was question 3. Question 4. In a box there are 5 black pens, 2 white pens, and 4 red pens. In how many ways can 2 black pens, 2 white pens, and 2 red pens be chosen? So still we are going to first deal with each at a time. Let's start with the black pens. Selecting 2 black pens from 5 is 5 combination 2, which is 10. Now we shall go to white pens. Selecting 2 white pens from 3 white pens is 3 combination 2, which is 3. Then we shall go to red pens. Selecting 2 red pens from 4 red pens is 4 combination 2, which is 6. Therefore, the total will be got by multiplying, which is 180 ways. Then question 5. In a group of 9 has to be selected from 10 boys and 8 girls. It consists of either 5 boys and 4 girls or 4 boys and 5 girls. How many different groups can be chosen? So the number of ways of choosing 5 boys and 4 girls is 10 combination 5 because there are 10 boys and you want 5. Then 8 combination 4 because they are 8 girls and you want 4. So using a calculator, I'll come up with that. What about number of ways of choosing 4 boys and 5 girls? 10 combination 4, 8 combination 5. Use a calculator to come up with that. Now because of this word or, the word and means multiplication, but the word or means addition. So it is this or this. Therefore you are going to add to come up with the total number of ways which they wanted. So now I'll leave you with an assignment for you to try out. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on solutions to the exercise and the assignment 1. So if you're not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family. Hello viewers, Daruna taking you through the story for O-level math contest practice. And this video I'm going to go through the solution for week 3 math contest exercise and assignment 1 for the year 2023. So this was our agenda for week 3. We already gone through day 1, day 2, day 3, and now we are on day 4 where we shall go through the solutions to exercise and assignment 1. So let's begin with the exercise. Question 1 says, a railway line goes up an incline at constant angle 4 degrees over a horizontal distance of 4 kilometers. So this 4 kilometers is a horizontal distance. How much altitude has the train gained by the end of the incline? So an inclined plane is something like a slope. This is what they call an incline. Then the horizontal distance is this AB. So it will be, first of all, the angle was 4 degrees. Then the horizontal distance AB was 4 kilometers. Now the altitude they want is this height. So let's call it X kilometers. The good thing you realize that this is a right angle triangle, so you can use SOHCAHTOA. Now for SOHCAHTOA, this angle is this is the opposite. So we're interested in opposite and adjacent. Opposite, adjacent is tan. So I'll come and say tan 4 degrees is equal to opposite, which is X, over adjacent. Then I'll cross multiply to come up with that line. Then use a calculator, I'll come up with this as the value of X. Therefore, the altitude will be 0.2797 kilometers. Then for question 2 says, a kite is attached to a 50-meter long string. The other end of the string is secured to the ground. If the kite is flying 35 meters above the ground level, find the angle theta that the string makes with the ground. So still, there will be a right angle triangle where this will be the point where the kite is, and this is the string. And they told us the string is 50 meters long, so you can put 50 meters there. Then they told us it is at a height of 35, so you shall put 35 there. Then they asked for the angle of theta, so you shall put theta there. Now our aim is to look for value of theta. What we have is the opposite and adjacent. Therefore, from SOHCAHTOA, opposite adjacent, we have, opposite and hypotenuse. Opposite and hypotenuse is sine. Therefore, we shall come and say sine theta is equal to opposite over hypotenuse. Our aim is to make theta the subject. So when this one goes this side, you get inverse sine. Now you know how to do that. So inverse sine of 35 over 50 will give you 44.43 degrees. Remember we said angles are written to 2 decimal places. And that is what they wanted. Then question 3 says, from a point A, which is 30 meters from the base of a building B. Now in the assignment I gave you, this comma was not there, but this comma is very important. Do you know what that means? It means that B is the base of the building. The angle of elevation to the top of the building C. Also this comma is not there, but the comma is very vital. It means that this C is the top of the building. Then they're saying is 50 degrees. So what is that 50 degrees? 50 degrees is the angle of elevation to the top of the building and to the top of the flagpole CD is 60 degrees. So you have 2 angles of elevations. Find the length of the flagpole. So here we shall need to make a sketch. We shall come and draw our ground. Now I think you realize how they draw the ground. Just draw a straight line, then you shade using these lines like this. That's how they draw a ground. We don't need too much art. Then they said a point A, from a point A, so that will be a point A on the ground. Then they shall have a building. Like I told you, you don't need to use too much art to draw a building. Just draw a rectangle and label it building. That's what they want. They told us 50 meters from the base. So this is the base of the building. So this point A will be 50 meters from the base of the building. 30 meters from the base of the building. That's why you see here the word, the distance, the measurement of 30. Okay, then they talked about this angle of elevation. is from this point to the top of the building. So I'll come and draw a straight line, then I'll put my angle of elevation of 56. Then they talked about a flagpole CD. The good thing we have point C, meaning from C go upwards, just draw a rectangle and call it a flagpole, so you don't need too much art. They told us the angle of elevation is 60, so I'm going to draw a straight line, and this will be the 60 they wanted. Find the length of the flagpole, so let's call it X meters. So because this is 30, so this is 60, for a right angle triangle, this will be 30, the balance, to make the angles of a triangle equal to 180. Then also, we realize that this is 60 and this is 56, meaning this balance here should be 60 minus 56, which is 4 degrees. So now you have got 4 degrees, which corresponds to this. Remember sine rule. Then this angle corresponds to this side, but we don't know it. So I'll call it y. Then I'll come and say, why don't I first get this value of y? So from SOHCAHTOA using triangle ABC, now I want to get this y, but I know this. So when I use this angle, this will be the adjacent and this will be the hypotenuse. So adjacent hypotenuse, it will be cos. Therefore, I'll come and say that cos 56 degrees is 30 over y. Then I will cross multiply to get this. Then I take this on this side to come up with that. Then I use a calculator and come up with the value of y to 4 decimal places. Now that I know y, I can use sine rule for triangle SCD. So sine rule says sine this over this is equal to this over sine that. So we shall come and say x over sine 4 is equal to this y, but we already got the value of y over sine 30, which is here. Then I'll take this one this side to come up with this, and now use a calculator. When I use a calculator, I'll come up with the value of x as that. And the good thing that x was the length of the flagpole, so I'll just conclude that the length of the flagpole is that. Then for question 4, a surveyor standing on a horizontal plane can see a volcano in the distance. The angle of elevation of the top of the volcano is 23 degrees. If the surveyor moves 750 meters closer, the angle of elevation is now 37 degrees. Determine the height of the volcano. So still we shall come and make a sketch of the ground. Then shall put where the observer is, who is the surveyor, and the volcano. We just draw a rectangle and label it volcano. They told us the angle of elevation is 23 degrees, so come and put your 23 degrees. Okay, then this statement says when he moves 750 meters closer, so shall he will be at the point C, so that this distance apart is 750 meters. And the angle of elevation has changed to 37 degrees, so come and draw your 37 degrees. They want the height of the volcano, so let it be x. Okay, so now we have got a right angle triangle. And because this is 37, the balance to make angles of the triangle will be 53 degrees. Also, the whole of this, because this is 23, the balance will be 67 degrees. And this 67 minus 53 gives you 14 degrees. So let this be y. So using sine rule for triangle ABC, so with ABC, I'm going to use sine rule. When I use sine rule, this y corresponds to this, and this corresponds to that. So I'll come and do that. Then I'll take this on this side to give you this. And next is to use a calculator to come up with the value of y. But remember, they want the value of x. So I'll still have to use this triangle. So using SOHCAHTOA, sine 37 degrees will be x over y, which is the hypotenuse. Then cross multiply and use a calculator. That will be the value of x. Therefore, the height of the volcano is this. And that's what they wanted. Then question 5 says the angle of elevation from a point on level ground to the top of a building 100 meters high is 22 degrees. Find part A, the distance of the point from the base to the building I think let's start with that. So shall make a sketch. They talked about a building, so shall put a building there, which is 100 meters high. Then they talked about the angle of elevation being 22 degrees, so join using a straight line, and that will be the angle of 22. So a good thing now we have a right angle triangle, and they want this distance of the point from the base of the building. So with this angle, this side is the adjacent, and this is the opposite. So adjacent opposite, using SOHCAHTOA, adjacent opposite is tan. So I'll come and say tan 22 is equal to 100 over x. Cross multiply and make x the subject. Then use a calculator, and what you get will be the value of x. So that means that the distance of the point from the base of the building is this. Now that is part A. What about part B? Part B, they want the distance of the point. The point must be moved towards the building in order that the angle of elevation becomes 40. So it will get a point closer to the building, and the angle of elevation will now be 40. Now they want this distance y, so let's call it y. Okay, so the good thing, we know this, we know the value of x now, we have got it. So if I get the value of z using this triangle, it implies that I can easily get the value of y, because y plus z is equal to x. So let's get the value of z. If I'm here, this will be adjacent and this will be opposite. So adjacent opposite, still it is tan. So I'll come here and say that tan 40 degrees is equal to 100 over z. Cross multiply and make z the subject. Then use a calculator to get the value of z. So now that I know z, I can easily get the required distance of y, which is x minus z. And that gives you that. So that was all about exercise. Now we shall go to assignment 1. Assignment 1, question 1 came from National Math Contest 2017, paper 2 of question 6. So the questions in this assignment were a little tricky and needed more interpretation. So let's go through them and you see, and you make corrections when necessary. So question 1 says, a lady drives at 40 kilometers per hour while going to visit her uncle. On arrival, she realizes that her uncle had gone on a trip. Okay. Immediately, she drives back to her home at 90 kilometers per hour. What is her average speed for the whole trip? So first, let's make a little sketch. So let D be the distance between her uncle's house and her house. So that means that if we are to sketch it, we don't need a lot of fine art. So we are going to just use lines to say that this is the lady's home and this denotes the uncle's house. So she first goes towards the uncle's house. The speed is 40 kilometers per hour. Then from her uncle's house towards her home, the speed is 90 kilometers per hour. But the distance between the two houses is the same. So let's call it D. Okay, so now we shall remember that distance is equal to speed times time. Okay, that means that time is got, when I make time the subject, this speed will come this side to become distance over speed. Okay, do you know what that means? It means that the time taken to move from her house to the uncle's house is distance, which is d, over the speed, which is 40. Okay, while the time taken to move from her uncle's house to back to her house is distance, which is d, over the speed, which is 90. Therefore, the total time will be this time from her uncle's house to from her house to the uncle's house, then plus the time from the uncle's house to back to her house. When I add the two using LCM, I'll realize that I'll come up with this. So how do you come up with that? First of all, when you get your cash, okay, first put this D out, which is here. Then you ask yourself, 1 over 40 plus 1 over 90, what does it give? So when you get the LCM, and you realize that you come up with 13 over 360. But a good thing, even the calculator can give you this answer straight away. You don't need to go through that work of primary. So in primary, remember, you are not allowed to use a calculator, but now you can use a calculator. So you can use a calculator and straight away you get this answer. So that is total time, but remember, average speed is total distance over total time. So the total distance is 2d. Remember, from here to here, it was d. Then from here back, it is also d. So d plus d gives a total distance of 2d. That is the reason why we are seeing 2d here for total distance. Then divide by this for the total time. Now, when this division becomes a multiplication, this fraction becomes a reciprocal. So we'll come up with this. And from this, you realize that this d can cancel. When it cancels, okay, this 2 times this gives you 720. Then denominator we have 13. And that is the answer. So if you use the calculator, the whole of this will give you this to 4 decimal places. So you can either choose to leave your answer in fraction form, or you give your answer to 4 decimal places. Then question 2 came from National Math Contest of 2017, paper 1, question 13, and says, if Bonnie and Mary leave their houses at the same time, okay, walking directly towards each other, okay, each at their own constant rate, they will meet after 5 minutes. If Bonnie leaves 3 minutes later than Mary, they meet after Bonnie has walked for 3 minutes. Okay, how many minutes would it take him to walk all the way from his house to Mary's house? So let's make a little sketch here. So let SBB denote the speed for Bonnie, and this denote the speed for Mary. And D denote the distance between their houses. So we shall make a simple sketch here, Bonnie's house and Mary's house. So Bonnie moves and takes 5 minutes. Also this one, when he moves and takes 5 minutes, they will meet at this point. And at that point, it means that Bonnie will have moved a distance dB and Mary will have moved a distance dm. And we already told us that this d total distance between the houses is d, so meaning that this plus this gives you the total distance. Okay, then you remember that distance is speed times time. Therefore, when you substitute, so that when they meet after 5 minutes, total distance will be distance moved by Bonnie plus distance moved by Mary. That is dB plus dm. And the distance is speed times time. So speed for Bonnie times the time taken plus speed for Mary times the time taken. These have unknowns, so we shall call it equation 1. When you see us putting equation 1, what should come to your mind is simultaneous equations. So let's go to the next case. They said, however, if Bonnie leaves 3 minutes later, do you know what that means? If I leave 3 minutes later, it means that I will take less time, okay, than Mary. They meet after Bonnie has walked 3 minutes. So that means that Bonnie will have taken 3 minutes, but Mary will take 3 plus 3. Because if Mary first moved for 3 minutes before Bonnie started moving, then when Bonnie started moving, the total time which was spent was 3 minutes. So the total time for Mary will be 3 plus 3. It is a little tricky, but if you internalize it, you realize it. So now that I've got the times, I'll come and say that the distance has now become, for Bonnie it is speed times time. This is speed times time. Now we have two equations, but there's something funny. Do you see something? This is D and also this is D, meaning they are equal. So I can substitute where there is D, I can put there this. Or I can say that let me equate the two equations since they're all equal to D. So when I equate the two, I'll come up with this. Now I have to collect like terms. So this is this, this is this, this is this, this is this. Now collecting like terms means put SB alone and SM alone. So when I put SB alone, bring this one this side, becomes 5 minus 3, which is 2SB. Then put SM alone, bring this one this side, it becomes 6 minus 5 to give you 1, which is this. That means that SM is 2SB. In other words, the speed of Mary is twice the speed of Bonnie. So I'll come and substitute equation 3 into equation 1. Remember that was our equation 1, so come and substitute. So where there is SM, I'll put there 2SB. So this is that, this is that. In the end, it gives you 15SB. Now there is something funny. Do you see this? Total distance. Then the speed for Bonnie, meaning this should be time from this formula. Because we know that distance, speed times time. So distance, speed, and this should be time. Therefore, time taken by Bonnie is 15 minutes. It was a little tricky, actually very tricky. Then question 3 came from National Math Contest of 2017, paper 2, question 13. And it says, in racing over a given distance at uniform speeds, John can beat Issa by 20 meters. Okay. Issa can beat David by 10 meters. Okay. And John can beat David by 28 meters. How many meters is the distance over which they are racing? So this one was also tricky, actually also very tricky. So questions of motion were very tricky. So 1, the word uniform means constant. In other words, their speeds do not change. Okay, now let small d denote distance. Why are we using small d? Previously, we have been using capital D for distance, but because there is this David, it means that I can't use capital D here because already capital D denotes David. Now I can't use capital D, that's why I've chosen to use small d. So let's go statement by statement. The first one said, John can beat Isa by 20 meters, and John can beat David by 28 meters. So we all have John here and John here. So that means that in the same time, when John covers d meters, Isa will have covered d minus 20. Because John is ahead of Isa by 20. Also, David will have covered d minus 28. Why? Because John is ahead of David by 28 meters. It was also a little tricky to interpret that. Meaning that if you have time equal to distance over speed, it implies that when you get distance over speed for each, they should be the same because it said same time. So this is not time taken by John, time taken by David, Isa, time taken by David. So they all the same because of this word same time. That is equation 1. And when you see equation 1, what should come in your mind is simultaneous equations. Now let's go to this other statement. There's this other statement of 10 meters. So let's look at it. So they said Isa can beat David by 10 meters. So that means that in the same time, if Isa covers d meters, David will cover d minus 10. So we shall come and equate the times, time for Isa and time for David. So we have now two equations. That means that somewhere there should be simultaneous equations. So from equation 1, I have that. So what I've done, remember equation 1 has 3 parts. So I've just chosen these 2. When I chose these 2, now why did I choose the 2? It is because if you look at this equation 2, we have David, Isa. So that means that even here, I should ignore John and go for David and Isa. That is why I've chosen these 2 equations. So cross multiply to come up with David, Isa. And also here you see you have David, Isa. Do you know what that means? It means we can equate the 2 equations. And when you equate, we have only D as the only unknown. Now we have moved. So the only thing we are now left with is to see how we can make D the subject. So let's try. The first thing is to cross multiply. This one goes with this side, but don't forget the brackets. Then start opening the brackets. So this with this is d squared. This with this is minus 20d. This with this is minus 10d. And this with this is plus 200. Then this side, this with this is d squared. This with this is minus 28d. So next is to simplify. This goes with this. Okay. Then here, this and this gives you negative 30d. Then correct like terms, what I've done, I brought this one this side. It becomes positive 30 minus 28 to give you positive 2d. Here remain with 200. So divide both sides by 2, you'll come up with the value of d. And that's what they wanted. So it was a little tricky and hard for you to interpret. So question 4 came from National Math Contest of 2016, paper 2, question 12, and says, Nancha and Chintu are driving on a circular track with radius 25 kilometers. Nancha leaves the starting line first, going clockwise around the track at a speed of 80 kilometers per hour. Okay. 15 minutes after Nacha starts, Chintu leaves the same starting point, going counterclockwise. In other words, Nacha was going this direction, Chintu goes in the other direction. Around the track at a speed of 100 kilometers per hour. For how many hours will Chintu have been driving when the two of them pass each other for the fourth time? So this one required you to make a sketch. So you come and draw a circle with the center and the radius is 25 kilometers. Then you so considering the first meeting, we shall put a starting point. So Chintu is this side, Nancha is this side. So Nancha is going to first move for 15 minutes, then the Chintu also starts, and somewhere they are going to meet. So let's analyze this. I want you to look at this motion. Nancha is going to start, and after some time, Chintu will also start. So notice this. So when Nancha reached somewhere here, this one also began. Let me repeat it for you to analyze it. So they are going to begin, go. Okay, so they reach at this point. Now I want you to notice something. This Nancha took more time than Chintu. Therefore, if Chintu took T hours, Nancha will have taken T plus 15 minutes, and 15 minutes is 15 over 60 hours. So you come and say that Chintu took T hours and Nancha took T plus 15 over 60 hours. There is time. What about distance? Distance, we are going to realize that this is now a circle. So the distance covered will be the circumference of the circle. So circumference of a circle is 2 pi r, and now r is 25. So come and substitute for r. You'll come up with 50 pi kilometers. So what do you know what that means? It means that if Chintu covers a distance of x kilometers, then Nancha will have to cover the remaining distance. So here you come as the distance is this. Therefore, the one for Nancha will be the balance, which is 50 pi minus x. Okay, so now that I've got the distance for each and the time for each, we can come and make our calculation. The distance is p times time. Therefore, for Chintu, we have distance is x, speed is 100, and time is t. What about for Nancha? Distance is 50 pi minus x, speed is 80, and time is t plus 15 over 60. Therefore, come and substitute, because we have two equations. Substitute for x. So this x here is 100t, so come and put it here to come up with this. Now here we have one unknown, which is t. So let's look for a way of making it the subject. The first thing is to open brackets. So this with this gives you 80t, this with this gives you 20. Then from there we shall collect like terms. Take this on this side to give you 180t, take this on this side to give you 50 pi minus 20. So when we divide both sides by 180, we shall come up with the value of t as this. Now what about the second meeting? Remember they asked for the time for the fourth meeting. So that was the first meeting, and let's first redraw the one for the first meeting. This is the same diagram we drew in the previous slide, but because I'm going to redraw it too so that I can add on the second meeting. So at first, this moved from here up to here, and this moved from here up to here. Now for the second meeting, it means this one is going to continue this side, and this one continue this side, and they also meet for the second time. So let's try to do that. So for the second meeting, it means that this will move, they will move and meet this side. I want you to realize something. You realize that they have taken the same time. Let me repeat it and you see it. It was like that, then they began moving at the same time and they meet at this point. So they have taken the same time. Therefore, for chain 2, the speed is that, the time is that, and the distance, let it be y. For Nancha, the speed is that, time is that, and the distance will be the balance. So I'll come and say that for chain 2, still using this distance equals speed times time, distance, speed, and time. Then also for Nancha, it will be distance, speed, and time. So you have two equations. We're going to repeat the same procedure. Substitute. So when I substitute for y, here I'm going to substitute for y. Where there is y, I put there this to give me this. So this word was supposed to be y. So now I have only t, and when I make it the subject, I'll come up with that. Now, this is what you should realize. If you go back to this diagram, the time taken for the first meeting from here to here, it was small t. For the second meeting, it is going to be capital T. And that capital T will be the same for the third and fifth because they are going to start from the same place and also take the same time and move with the same speed. Therefore, I'll come and say that the total time now will be small t plus capital T plus capital T plus capital T, which is small t plus 3t, which gives you small t is here and 3 is here and capital T is there. So simplify by getting LCM, and that will be the value. So we are just simplifying. So that will be the time they wanted. Then for question 5, came from National Math Contest of 2017, paper 1, question 11, and says, George's car gets 3 more kilometers per liter during highway driving than it does during city driving. On a recent trip, he drove 112 kilometers on the highway and 150 kilometers on the city and used exactly 10 liters of petrol. How many kilometers per liter does his car use during city driving? So shall come and say that let X be the kilometers per liter his car gets during city driving. Therefore, the number of liters for city driving will be 150 over the kilometers per liter, which is X. What about for highway? Remember highway, they said he uses he gets 3 kilometers more. He gets 3 more kilometers per liter. So it will now become X plus 3 here. Therefore, the total liters will be this plus this. But I said the total liters is 10. That's why you equate here to 10. Then you can get an equation. So what I've got done, I've got LCM. LCM is X times X plus 3. Then this LCM divide by X. You remain with X plus 3 times 150 to give you this part. Okay. Then also this LCM divide by this, you remain with only X times 112 to give you 112X equal to 10. Then I will cross multiply and open brackets. Then simplify. Collect like terms. Now what I've got is a quadratic. Let me first reduce it. So dividing through by 2 gives you that. So this is a quadratic equation, so I can choose any of the two methods, either using the quadratic formula or the method of factorization by splitting the middle term. So if I choose splitting the middle term, I'll need 2 factors whose sum is negative 116 and product is negative 1125. So those 2 factors are negative 125 and 9. Therefore, I'll come and replace the middle term with these two factors and factorize each group by grouping. So this first group, the factorization is this, for this, the factorization is this. So you've already watched the video of factorization of algebraic expressions in week 1, I believe. By now you know how to factorize. So this with this gives you this, and this comes here. Either this is equal to 0 or this is equal to 0, therefore x is this from here and x is this from here. But x cannot be negative, therefore x is 25. So I'll conclude that the number of kilometers per liter his car gets during city driving is 25 kilometers per liter. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solutions to assignment 2. So if you have not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family. Hello viewers, Wagdaruna taking you through this scenario for O-level math contest practice. And this video we are going to go through the solutions to week 3 math contest assignment 2 for the year 2023. So this has been our agenda for this week, and day 1 was covered, day 2 was covered, day 3 was covered, day 4 was covered. And now we're going to go through the solution for assignment 2, which was left in the video for day 2. So question 1 came from the National Math Contest of the year 2018, paper 2, question 15. And it says, in triangle ABC, angle BSC is 30 degrees. Angle ABC is right angle. The point D lies on AB such that AD is equal to 2 centimeters and the angle CDB is 45 degrees. What is the length of BC? So here there's no way you can run away from sketching. So the first thing to do is to make a sketch. They told us it is right angled at B, meaning that our point B will be here. They said BSC is 30 degrees, so shall come and put 30 degrees there. Then angle ABC is right angle, so shall come and put a right angle there. Then point D lies on AB such that AD is 2 centimeters. So shall come and put point D somewhere such that AD is 2 centimeters. Then they said angle CDB is 45 degrees, so we shall come and put our angle 45 degrees. Then I think you remember under Pythagoras theorem that if this is 45 degrees, then the two legs are of the same length. And now because we have already drawn our sketch, you don't need to again rub off and make sure these sides are equal. Your aim is to come and put their two unknowns which are the same. Then you can now use SOHCAHTOA for triangle ABC. So for triangle ABC and using this angle, you realize that this x is the opposite and this is the adjacent. So that means that we're going to use tan. So tan is equal to x over x plus 2. Then cross multiply, take this on this side. You remember to put it in brackets. Then open brackets, you come up with this. So this gives you this, and this by this gives you that. Now we want to collect like terms. You see there is x here and also x there. So we have to take them on one side, take this one this side to come up with this. Then you realize that in this x is common. So pull it out. Okay. Now we have our x which is isolated. Next is to divide both sides by this whole bracket so that we make x the subject. Okay, so now after achieving that, next is to use your calculator to come up with the value of x. Now, you realize that when you press your calculators, you don't get this. It is because of the type of the calculator. So the calculator which gives that is called FX991ES. So most of you have FX991MS. So MS will give a decimal, but ES will give a SAD. And also this one will give a SAD. So this expression is under the topic of SADs, and we shall learn it before you participate in the national math contest. But for now, ignore it and get this from your calculator, and that's what you should write. Then question 2 came from National Math Contest of the year 2018, paper 1, question 7, and says, in triangle ABC, D lies on BC so that SC is 4 centimeters, AD is 4 centimeters, BD is 8 centimeters, and CD is 1 centimeter. Find the value of angle ABC. So still we shall need to make a sketch. Now the question is, why do we put A here and not here? It is because of this other additional information. They said D lies on BC. So that means that it is advisable to make BC horizontal. That's why you see it here, horizontal. Then making it horizontal, you have to remember that as you label anti-clockwise. So you don't expect you to put B here and C here. That would be clockwise. Then it told us about point D lies on BC such that SC is 4 and this AD is 4. So that means that this triangle forms an isosceles. I know something about isosceles. A perpendicular meets the midpoint of DC. Then they told us that BD is 8. Then if CD is 1, it means that the perpendicular from A will divide DC into 2. So one will have a half, another will also have a half. Then they want angle ABC, so which is that. Let's call it an unknown. Then we look for a way of getting it. 1, by using Pythagoras theory for A is C, this one. We have the hypotenuse, we have one of the legs, we can get the other leg. Substitute in Pythagoras, simplify. Collect like terms, put square root. So like I told you, still this one is for calculators which have ES. But for you from here, I expect you to get this. Then using SOHCAHTOA for triangle ABE. SOHCAHTOA means this angle is theta. This angle is theta, so we have this H, which is opposite, and this is adjacent. Therefore, we are going to use tan. So tan theta is equal to this H, which you have got, divided by 8.5, because this gives you 8.5. That means that tan theta will be 25.3 degrees. As in, the angle they want is 25.3 0.03 degrees. Then question 3 came from the National Math Contest of 2016, paper 2, question 2, and says, in triangle ABC, AB is 3, BC is 4, and SC is 6. If BC is extended through C to D so that CD is equal to BC, what is AD? So we shall come and make a sketch of triangle ABC. Now still I realize that this A is up and BC is here because they taught something about BC. They said BC is extended through C to D. So there's something being done on this BC. That's why we choose to make it horizontal. Then we shall put the sides given. SB is that, this is that, and that is that. Then we talked about BC. Extending means we make it longer to point D, such that CD is equal to BC, meaning that if this is 4, this will also be 4. So what is AD? So we need to join using a straight line AD. And the one that distance, let's call it X. This angle, let's put this angle to help us get this angle will help us get the value of X using cosine rule. Then this one, but you can't get beta without getting theta. That's why I also put here theta. So let's start with theta. So using cosine rule, theta corresponds to 3. So we shall start with 3 squared equal to these other two sides, which is this squared plus this squared minus 4 squared minus 4 times 3, sorry, times 6 times cos theta. Then simplify, collect like terms, you'll come up with that. So I'm taking this on this side and this on this side to come up with this. Then make cos theta subject by dividing through by 48. Then get theta by getting inverse cos, which gives you that. So now I've got this angle, meaning I can get the angle of beta. For angles in a straight line, they add up to 180. I think you remember that. So we shall come and substitute for theta and get the value of beta. Now that we have beta, we can now use cosine rule. So x squared is equal to this plus this minus 2 times this times this, cos the angle. Then you simplify, this is this, this is this, then the whole of this is here, then cos this is a negative. Now negative and a negative gives a positive. So these two are this, then these ones gives this positive. Then you add to get this, put square root, and that will be the value of x. So like I told you, this is for the calculator of ES, but for you I expect you to get this. Therefore the length AD which they wanted is that. Then question 4 came from National Math Contest of 2016, paper 1, question 14. And it says, ABC is a right-angled triangle. Point DEF are on the sides AB, SC, and BC, respectively, such that AD is equal to AE and CE is equal to CF. Find angle DEF. So we're going to make a sketch of a right angle triangle. So when they say ABC is right angled, it means that this middle value is where the right angle is. Now these angles, we don't know them, we shall let this be x and this be y. But they talked about these points DEF. D is on AB, so we shall put D on AB. Then E is on SC. But the good thing is that AD is equal to AE. That's why you see here, these to denote isosceles triangle. Therefore, if this angle is P, this will also be P. Then they talked about F. F is on BC. So shall come and put F on BC such that CE is equal to CF. You can see this, meaning this angle is equal to that angle. Now they want angle DEF, which is 2. So we should look for getting the value of 2. Let's start with the big triangle ABC. When you add all the angles, you get 180, meaning that y is equal to 90 minus x. So now we shall go to the isosceles triangle ADE. Interior angle sum is 180. So take this one this side to give you this, and divide both sides by 2 to give you that as the value of P. Remember, our aim is to get 2. So let's now go to this isosceles triangle. So you have that. But remember that we saw that y is equal to 90 minus x. So let me substitute for y, where there is this y, I put there 90 minus x. Then my aim is to make r the subject. So the first thing to do is to take this 90 this side. So 180 minus 90 gives 90. And also take this negative x this side to become positive. Then divide both sides by 2. Okay, now I have P and R in terms of x. I remember that angles on a straight line add up to 180. So when I add this plus this plus this, I should get 180. That should be in my mind. So substitute for P and for R. Then get the LCM. LCM, this is like 2 over 1. So this divided by this is 1 times this to give you this bracket. 2 divided by 1 is 2 times 2 to give you 2. 2 divided by 2 is 1 times this to give you that. Then open the brackets and then cross multiply. Take this one this side and also open brackets in the numerator to give you this. Then try to collect like terms. There's something funny. The funny thing is that this x is going to cancel. So you're going to remain with 180 plus 90 to give you 270. Then 2 and this side 360. Take this one this side to give you 90. Then divide both sides by 2 to give you that. And that's the angle they wanted. Question 5 came from National Math Contest of 2015, Paper 2, question 15, and says, point P is inside an equilateral triangle, ABC. Point Q, R, and S are the feet of the perpendicular from P to AB to BC and to CA, respectively. Given that PQ is 1, PR is 2, and PS is 3, what is AB? So we're going to first come and make a sketch of the equilateral triangle. Then shall locate point P somewhere such that PQ is 1, so a perpendicular from P to AB is 2. Perpendicular from P to BC is R. Perpendicular from P to SC is S. Then we shall remember that PQ is 1, PR is 2, and PS is 3. So they want the distance AB. Now because it's an equilateral triangle, all sides are equal. So we shall let the sides be x. So AB is x, BC is x, SC is x. But still that is not enough. So what we're going to do, we are going to divide this triangle into 3 triangles. So we are going to join this to this, this to this, and this to that. Because so far what we have cannot help us to get the side AB. So let's divide into 3 triangles. You realize that each triangle has a height. this has a height, this has a height, this has a height. Therefore, we are going to use areas. That area of ABC is equal to area of triangle PAB plus area of triangle PBC plus area of triangle PAC. So let's substitute area for triangle ABC. It will be a half AB sine theta. I think you remember we said that when you have two sides and an included angle, you can get this area. So in this case, because it's equilateral, this angle is 60, this side is x, this side is x. So it means a half times x sine 60. Okay, but for these other ones, the good thing we already have the height. So for triangle PAB, height is this and base is 8. Sorry, base is x. Height is this, base is x. Height is this, base is x. To give you that. So now we have an equation with only one unknown, which is x. And remember, x is the side AB. So when you make x the subject, we shall have got what they want. So let's start to simplify. This gives you 0.5x squared, then you add on the sine 60. Now you can use a calculator to get sine 60, but it's better to do that at the very end of the calculation. So let's first maintain the sine 60. This gives you that, this gives you this, and this gives you that. So collected like terms, the whole of this gives you 3x. Here 1x can cancel to remain with that. Now I can make x the subject by dividing both sides by 0.5 sine 60. And when I press the calculator to give me this, if I have ES, but for you I expect you to get this. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on assignment 3. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit as a family. Hello viewers, Daruna taking you through the story for O-level math contest practice. And this video I'm going to go through the solution for week 3 of math contest assignment 3 for the year 2023. So this was our agenda for this week 3, and what is ticked means is already available on this platform. So today in day 5 we are going to go through the solution for assignment 3. So this assignment was basically on the concept of simultaneous equations. Remember in week 1 we covered simultaneous equations, but we didn't do an assignment on simultaneous equations. So this video is basically on those who have watched video of simultaneous equations. So question 1 came from the National Math Contest of year 2010, paper 1, question 2, and it says two non-zero real numbers. Non-zero means A cannot be 0 and B cannot be 0. Satisfy the relationship that A times B is equal to A minus B. Find the value of A over B plus B over A minus AB. So we shall first quote what is given and get the LCM. So LCM is AB. So AB divided by B remain with A times A to give you A squared. Also AB divided by A is B, B times B is B squared. Then minus AB, so this is like over 1. So AB divided by 1 is AB times AB to give you AB squared. But we know that AB is equal to A minus B. Therefore, I'll come and substitute. Where there is AB, I'll put there A minus B. Then from there, I will open brackets. I think you remember this expanding a perfect square. You square the first term minus the product, twice the product of the two terms, which is this, then plus the square of the second term. That was also looked at in the week 1 of expansion of algebraic expressions. So open this bracket further, this and this gives you positive, that's why you see positive here. Then this negative and positive gives a negative, that's why you see negative here. Then we are going to correct like terms. We are going to realize that this and this can cancel. Also this and this can cancel. So we are going to remain with 2AB over AB. Now also this and this can cancel and this can cancel. So we are going to remain with 2, and that's what they wanted. Then question 2 came from the National Math Contest of 2016, paper 1, question 2, and says, let capital A plus capital R be 17, capital R plus capital M be 1, and capital M plus capital L be 24. Compute capital A plus capital L. So we're going to first list them down because now we need simultaneous equations. So when we add all the 3 equations, this is what we are going to get. The whole of this is here, this is here, this is here. Then left hand side we have this, this, and that. So collect like terms, you realize that this and this gives you 2R, this and this gives you 2M. Then the whole of this gives you 42. Then here this and this has a common factor, which is 2. So inside will be R plus M. And the good thing, we know that R plus M is equal to 1. So I'll replace it with 1. When I replace with 1, I realize that these 2 can go this side to become 40. And that's what they wanted. Then question 3 came from the National Math Contest of 2013, paper 1, question 1, and says xy is equal to 2, yz is equal to 24, zx is equal to 3, and xy and z are all positive numbers. What is the value of x plus y plus z? So we have the 3 equations. What we are going to do, we are going to divide. So equation 1 divided by equation 2, I'm going to come up with this. This over this is equal to this over this. So this y can cancel and remain with x over z. And here reduced to 1 and here 12. This is 1 over 12. So that gives us equation 4. Then also substituting 4 into equation 3, here I'll come up with this, because where there is z, I'm going to put there 12x. So that gives you 4x. Why is it 4x equal to 1? 4x squared equal to 1? Because x times x is x squared. Then here 3 and this one, it reduces. So this reduces by 3 to give you 1, by 3 to give you 4. Then divide both sides by 4 and put square root to give you pos. Now, when you put square root, it will be plus or minus, but they told us that they are all positive. That's why I only take a positive value. Then from equation 1, since we know the value of x, we can come and substitute, then get the value of y. Also, from equation 4, we know the value of x, so we can substitute to get the value of z. Therefore, now that I know x, y, z, I can get the required expression. So substitute and add to come up with 10.5. And that's what they wanted. Question 3 came from the National Math Contest of 2010, paper 2, question 7. And it says, find the value of this given that this is equal to 6 and this is equal to 60. So first of all, from here, I'll make y the subject to give you y equal to 6 minus x. Then from this one, I'll substitute for y. When I substitute for y, I'll get an equation which has only x. So open brackets, this is that. Then 3x times 6 gives you 18x. Then 3x times x gives you negative 3x squared. Then here 2 times 6 gives you, okay, here what I did, remember there's a perfect square here. So let me first deal with this perfect square. So this gives me square the first term, then times twice the product, minus twice the product of the two entries. 2 times 6 times x gives you 12x. Then square of the second entry. All that was seen in the video of expansion of algebraic expressions. So when I bring these two inside, this with this gives you 72, this with this gives you negative 24, this with this gives you 2x squared. So collect like times. When we realize that this minus this gives you minus 2x squared, but we also have plus 2x squared. So this, and this gives you 0. Okay, then this 18x and this. So 18x minus 24x gives you negative 6x. The 72 is here and this x is here. Then again, collect like terms. Take this 72 this side to come up with this. Simplify and divide both sides by negative 6 to give you the value of x. Then what about the value of y? So when x is that, come here and get the value of y. So y is 4, meaning that I can get this expression. So substitute for x and y, simplify and get the answer. For question 5, came from National Math Contest of 2012, paper 1, question 13b, and it says, a bottle and a glass together hold the same amount of water as a jar. Okay. A bottle holds the same amount of water as a glass and a tankard together. 3 tankards hold the same amount as 2 jugs. Okay. How many glasses would 1 tankard hold? So this was also a little funny, but it involved simultaneous equations. So let's go statement by statement. The first thing to do is to let each item with a letter. So this B will denote bottle, G will denote a glass, J will denote a jug, and T will denote a tankard. Then we start. The first statement was, a bottle and a glass hold the same amount of water as a jar, meaning B plus G is equal to J. Okay. So when I take everything on one side, I'll come up with this. Call it equation 1. Then we got the next statement. The next statement said, a bottle holds the same amount of water as a glass and a tankard together. So B is equal to G plus T. Put everything on one side, you come up with equation 2. Okay. Then we got the next statement. 3 tankards hold the same amount as 2 jugs. 3T is equal to to j. So put everything on one side, you come up with equation 3. The question requires us to obtain t in terms of g, implying that we are to eliminate b and j. So to eliminate b and j from equation 1 and 2, I'll need to subtract the two equations. When I subtract, first of all, this b will go away, and this will give me 2g. Then negative j is there. Then 0 minus t gives you positive t. So I've eliminated b, but j is still there. What should I do for j? So still I'll go to equation 3 and equation 4. Equation 3 and equation 4, if I multiply 2 through equation 4, I'll come up with this. So 2 times this is 4g, 2 times this is 2j, 2 times this is 2t equal to 0. Then minus, when I subtract this, j will cancel. Now I'm left with t and g, which is what I want. So t is equal to 4g. Do you know what that means? It means that one tankard would hold 4 glasses. And that's what they wanted. So that brings us to the end of the video. Thanks for watching, and since this next week we shall be going back to our schools, so now the next videos will now no longer be for math contests. They will now be for the normal videos being uploaded, NEB videos. So I wish you luck in your term 3, and I encourage you to spread the news to other students so that they can also join and benefit. Hello viewers, Wagadaruna taking you through the story of O-level math contest practice. In this video, I'm going to go through the solutions to week 3 math contest assignment 1 for the year 2023. So this assignment is under geometry. Question 1 says, a circle is inscribed in a right angle triangle measuring 3 centimeters, 4 centimeters, and 5 centimeters. Without use of construction method, find the circumference of the circle. So the first thing to do is to extract out the right angle triangle. There are 2 methods, and we're going to look at both of them. One is using areas, method of area, but all methods begin with first sketching out the information given. So shall come and draw a right angle triangle with those sides, because if they say 4, 5, 3, 4, 5, it's a right angle triangle, meaning the longest side must be this. Then here it is you to choose what to put. It is okay to put 3 here and 4 here, but this must always be 5. Then you shall come and sketch a circle. Remember, we are not using any construction method, we are just sketching. So sketch a circle touching all sides. That's what they mean by inscribing. Then how is this method of area used? You are going to divide this triangle into 3 parts. The first part is by joining from center to the vertices. So when I join to vertex A, that's what I'll get. Then I also join to vertex B, then also from center to vertex C. So now I have 3 triangles. There's this triangle, and this triangle. And the good thing is that all the 3 triangles have the same height. For example, for triangle AOB, the height is R, which is the radius of the circle. For triangle COB, that is the height, which is R. And for triangle AOC, that is the height, which is also radius R. Meaning I can easily get the radius of the triangle by saying area, radius of the circle by saying area of the whole triangle, rectangle triangle, is equal to area of the 3 divided small triangles. So let's come and substitute. For the big triangle, this is the height, this is the base. So it gives you a half base height. For A of B, for this one, the base is 4, the height is r. So half times 4 times r. For B or C, the base is 5 and height is r. For A or C, base is 3 and height is r. Meaning when I simplify, I will remain with only r as the unknown. Therefore, collect like terms and get the value of r. That is the radius, but remember they ask for circumference. But the good thing is that when you have the radius, you can easily get the circumference from 2 pi r. So substitute for pi, 22. So there are 2 ways of substituting for pi. One can choose to use the fraction, which is 22 over 7. You'll get this. Another can choose to use the decimal, which is 3.14. You'll get this. Any of the 2 is okay. That was method 1. Then method 2, by using circle properties, but still let's also first redraw. The same triangle we drew in method 1 is the same triangle we are going to draw here. It's only the approach to the question which will differ. So here, I think we realize something. This line, if this is the point where the circle touches, it will divide that line into 2, A, R. Also divide that into 2, A, B. Now, do you see something? This A and this A are the same. That is what I meant by circle properties. If these are 2 tangents from a common point, then they must be equidistant. Same applies to this common point. These 2 are tangents, so they must be equidistant, which is that. Also here, common point, tangents, they should be equidistant. Now, why did I choose R here? It is because from here to here is the same as from here to here. Same applies from here to here is the same as from here to here. After that, I'll come and say that for AB is got by adding A to B. What about BC? BC is R plus B, and CA R plus A. Now I have 3 equations, but for unknowns. Then let's see how to deal with them. Sorry, 3 equations, 3 unknowns, because there is 1, 2, and 3. Okay, that is good. So when I have 3 equations and 3 unknowns, it means I can solve simultaneously. Let me start by adding these 2 equations. When I add, R plus R is 2R. Then B plus A is that. Then 4 plus 3 is 7. Okay, but you realize there is A plus B here, which is 5. So I'll come and substitute for A plus B to give you 2R. This one is replaced by 5, and that's 7. Take this 5 this side to get 2R equal to 2. Divide both sides by 2 to get R equal to 1. So I think it is the same R we got in the first method, meaning I can now proceed to get the circumference as already seen. That was question 1. Question 2 says, PQR is a triangle such that PQ is 19, QR is 18, PR is 17. Let S be a point on PQ, okay? T be a point on PR, okay? And U be a point on ST such that QS is equal to SU and UT is equal to TR. So we shall come and first make a sketch of the information given. So we shall draw triangle PQR. Then they said S is on point P2. So come on P2 and locate S. Then T is on line PR. So come at PR and put T. Then U is a point on ST. ST, so meaning I have to draw a line and put point U. But they said QS is equal to SU. So QS and SU are equal. Also UT is equal to TR. UT is equal to TR. Find the perimeter of triangle PST. Okay. So perimeter is equal to this plus this plus this, which is here. Okay. But this ST has two parts. There is SU, then also UT. So shall split into two. ST is SU plus UT. Okay. Then we are told that SU is the same as QS and also UT is the same as TR. So come and substitute for SU. Where there is SU, you put QS, and where there is UT, you put TR. Okay. Then we are going to do something. We are going to group these two. Do you know why? Let us see where they are. PS from here tier. Then QS from here tier. Meaning when you add the two, you'll get P2. Okay. What about TR? TR is here. And TP is here. When you add the two, you get PR. So this two will give me P2 and this will give me PR. The good thing I know P2 is 19 and PR is 17. So come and substitute. When you add, you'll come up with perimeter as 36 centimeters. Then question 3, let ABCD be a rectangle and let P be a point inside the rectangle. If PA is 8, PB is 4, and PD is 7, what is the value of PC? So still the first thing to do is to make a sketch of the information given. We shall put point P anywhere inside the rectangle. Then they said PA is equal to 8. So join A to P and call it 8. PB is 4. So join B to P and call it 4. PD is 7. Join P to D. Call it 7. Then what is the value of PC? We have to join P to C. And this is what they want. So the easiest way to get it is to first divide the rectangle into 4 by drawing horizontal lines which can meet at 90 degrees at the sides. The reason why we are doing that is to bring in the element of Pythagoras theory. So we shall now, this is right angle, all of them, put right angles there, because what we want is Pythagoras theory to come into play. Then we don't know this distance, call it x, and this one call it y, this one call it u, this one call it v. Those are all unknowns. Now the length they want is PC, which can be got from this triangle. And by the Pythagoras theory, PC squared is equal to y squared plus u squared. So in short, you have to get the value of y and the value of u and then substitute them here. But how can we do that? We shall need to use other triangles whose hypotenuse is known. For using this as hypotenuse, it means y squared plus v squared is equal to 4 squared. What about when I use this as hypotenuse? It means x squared plus v squared is equal to 8 squared. Then what about when I use this? It means x squared plus u squared is equal to 7 squared. Okay, so now I have 3 equations. How many unknowns? 1, 2, Okay, 1, 2, 3, 4. Okay. So let's see how we can look for a way of getting this by solving simultaneously. Let me first add equation 3 to and equation 1. This and this. When I add the two, what will I get? I'll come up with v squared plus y squared plus x squared plus u squared is equal to 4 squared plus 7 squared. Okay. But you realize that from here, v and x, v squared plus x squared are equal to 8 squared. And also here we have this and this. So I can replace them with 8 squared and remain with 8 squared plus y squared plus u squared equal to 4 squared plus 7 squared. Okay, let me take this one this side. I'll come up with that. Use the calculator to simplify. The whole of this will be equal to 1. But remember, this y squared plus u squared is equal to pc squared, meaning I can get pc by getting square root. And that is the answer they wanted. Then question 4, modify the right-angled triangle with sides 11, 60, 61 by doubling the length of its shortest side, but keeping its perimeter and largest angle unchanged. What is the length of the new triangle's hypotenuse? So we shall come and first make a sketch. The original right-angle triangle, it had sides. Of course, the longest must be the hypotenuse. Then these ones, it is you to choose where to put them. Then the new triangle now, this has been doubled. But these ones, we don't know them. Then they ask, what is the value of y? Now first we shall say perimeter of original triangle will be given by adding this, this, and this, which is 132 units. Perimeter of the new triangle, you add this to this to this to give you that. So the good thing they told us that the perimeter, keeping its perimeter and largest angle unchanged. So perimeter remains unchanged, meaning I'll equate this to this. When I equate, simplify. Now here, remember I want y, so my aim is to eliminate x. That's what I'll make the subject. Okay. Then for the new triangle, I'll use Pythagoras theory, where y squared is equal to x squared plus 22 squared. I don't want x, so I'll substitute for x. And then expand this. Then I'll simplify, realize that this and this can cancel, so this side will remain with 0. Then this gives this, then the whole of this is 220y plus that. Then collect like terms, take this one this side, you'll come up with 220y, then this plus this gives you that. Then divide both sides by 220, you'll come up with the value of y, and this y is the hypotenuse. Therefore, we have got the answer they wanted. Then question 5. In the diagram below, px is a tangent to a circle of a circle at A. Px is a tangent here, okay? Py is the tangent to the circle B at B. Py here, tangent here. And CD is a tangent to the circle at E. Here, tangent is there. If PA is 15, find the perimeter of triangle PCD. PCD. So first we need circle properties. That if there is the common point and these are tangents, then they are equidistant. Therefore, PA is equal to PB, which is 15. That is 1. 2, CA is equal to CE, because the point and is the tangents. Then DB is equal to DE, because the point and is the tangents. Therefore, perimeter PCD will be equal to PC plus CD plus DP. Then this CD, if you look at it, is divided into 2. There is CE and DE, which is this. Okay. Then when you, from here, CE is equal to CA. Then ED is equal to DB. Then group, if I say PC and CA, let's try. PC CA gives you PA, which was 15. Okay. Then DB and DP gives you PB, which was also 15. So the answer would be 30. That's what they wanted. So now I'll leave you with assignment 2, still on geometry. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on solutions to assignment 2. Hello viewers, welcome to Daruna, taking you through the story for O-level math contest practice. In this video, we're going to go through the solution for week 3 math contest assignment 2 for the year 2023. So this assignment was entirely on geometry. So question 1 says, find the area of the largest triangle that can be inscribed in a semicircle whose radius is r. So the first thing to do is to sketch a semicircle, and also, so the largest area must have a base of the diameter of the semicircle, and the height, so here the height will be the radius, the maximum height will be the radius. So we shall get a triangle with base of 2r and height of height of r. Therefore, the largest area will be a half base times height, which is r squared. Question 2 says, suppose a rectangle has an area of 3 and a diagonal of length 10 root 10. What is its perimeter? So we have first sketch. So let x and y denote the length and width of the rectangle. So we come and get the rectangle ABCD, then the diagonal, it was root 10, then x and y are the length and width. So the good thing, this is the right angle triangle. And also they told us area is 3. So area is length times width. Therefore, x times y is equal to 3. Then also from this right angle triangle, using Pythagoras theory, the length is square root of x squared plus y squared, which is equal to root 10, which is the hypotenuse. Square both sides, we'll come up with equation 2. So I have 2 equations and 2 unknowns. But they want perimeter. Perimeter, remember, is twice the sum of length and width. So if we have here powers and here the product, it implies that to easily get this, we first square. So this squared will be equal to x squared plus twice the product of the inner entries, then plus y squared. When I rearrange this with this, pair them together and this alone, say that I can substitute for that and also for that. So when I substitute, this will become 10 and this will become 3, which is 10 plus 6, which is 16. Therefore, this squared is 16, meaning that this plus this is the square root. Therefore, x plus y without a power is square root of 16, which is 4 times 2 to give you 8. Then question 3, equilateral triangle DEF is inscribed in equilateral triangle ABC as shown below, and DE is perpendicular to BC. DE is perpendicular to DC. Find the ratio of the area of this triangle DEF to the area of triangle ABC. Remember, both of them are equilateral triangle, and what we know is that for equilateral triangle, each interior angle is 60 degrees. So I'll come and put 60 degrees here, here, and here for the bigger triangle. Also, DEF is equilateral, so each interior angle will be 60 degrees. Okay. Then to complete, because this is 90, this is 60, the remainder to make 180, to make an interior angle sum of 180 is 30 here. And when that is 30, angles on a straight line add up to 180. So this plus this is 90, meaning that the remaining one is also 90. Okay. So we shall come and let DC be equal to x. Then let us put x here. So I have right angles, meaning I'll need to use Pythagoras theory somewhere. So for triangle CDE, this triangle, so I can use Pythagoras theory, but the good thing here, I have the angle and this side, which becomes easier to use SOHCAHTOA. So from SOHCAHTOA, which we covered in the previous holiday, cos 60 degrees is equal to DC over EC. DC is the adjacent, EC is the hypotenuse. So cos 60 is a particular angle and it gives a half. If you use the calculator, you will find out that this is true. DC, we said it is x, meaning I can get EC in terms of x. Now I have this one. What next? I'll also use sine 60. Sine 60 is equal to ED, which is opposite over hypotenuse, which is EC. So I substitute for EC. Sine 60 is root 3 over 2. Think you remember that. EC is 2x, meaning I can make ED the subject. Then for triangle DEF, the good thing now I have DE and D, because if I have this, it means it is the same as this and same as that. So they're all equal to x root 3. Then for the right angled triangle AEF, tan 60 is equal to opposite over adjacent. Opposite tan 60 is here. Tan 60 is here, meaning the opposite is here, and adjacent is this. So opposite is FE, adjacent is AE. And I know FE. FE is x root 3, tan 60 is root 3, I can get AE. So AE will become x, because this cancels. So I have AE, and I also have EC. From here, EC is this, AE is this, meaning I can get now SC. S is got by adding, and it will be equal to 3x. Then area, I think remember this formula, given two sides enclosing an angle, the area is a half times those sides times sine 60. So SC was 3x, BC 3x, in the end we'll come up with that. Then also area DEF, EDEF, you come up with this. Then the required ratio was this area to this area. So substitute the areas, then look at what cancels. This will cancel, this will cancel, this will cancel, and here 1, here remain with 3. So the ratio is 1 to 3. Question 4. The circle below has center O. OA and OB are radii, and angle AOB is a right angle. A semicircle is constructed using segment AB as its diameter. The shaded portion of the semicircle outside circle O is called a lune. Here, what is the ratio of the area of the lune to the area of the triangle? So first, area of triangle AOB, half base times height, which is this. Then from Pythagoras theory, I can get this diameter, which will be r root 2. Therefore, area of semicircle, this semicircle, a half pi r squared. So substitute for AB, which you know, and this will be the area of the semicircle. Then also area of the quadrant AOB, a quarter pi r squared. Area of the minor segment AB is equal to area of quadrant minus area of triangle. Area of minor segment is this. This one will be equal to the area of the whole of this quadrant minus area of the triangle. So substitute, and that is it. Then area of the shaded part will be equal to area of semicircle minus area of minor segment. Semicircle minus segment. You realize that this and this cancels, this and this gives positive, then you positive what? Positive a half r squared. Therefore, the required ratio will be area of the lune to area of triangle AOB. So on cancelling, we remain with 1, a ratio of 1. Question 5 says 3 circles of radius 1 meter are mutually tangent as shown in the figure. What is the area of the shaded region? So these are 3 touching circles. The first thing to do is to show their centers, then you join the centers. When you join, you realize that the centers pass through the point at which the circles touch each other. But all have a radius of 1, meaning that here this will be 1, 1, 1, like that. Then this is equilateral triangle, that's why there is 60, 60, 60. Okay, so area of sector BDE, this sector, is equal to 60 over 360 times pi r squared, which gives you pi over 6. So all the three sectors have equal area, this, and this. Therefore, area of the three sectors is got by multiplying this by 3 to come up with pi over 2. Then area of triangle ABC is got from this formula, substitute for AB and BC. You'll end up with root 3. Area of the shaded region is equal to area of triangle ABC minus area of the three sectors, which will be equal to this minus this. So now I'll leave you with assignment 3, still on geometry. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on solutions to assignment 3. Hello viewers, Wagadaruna taking you through the story for O-level math contest practice. And this video I'm going to go through the solutions to week 3 math contest assignment 3 for the year 2023. So this assignment is entirely on geometry. So question 1 says, a teacher asks each student in her class to draw a rectangle whose sides are whole numbers and having a perimeter of 502 centimeters. When marking her students' work, she discovers that the students drew all the different possible rectangles. How many different rectangles did the students come up with, and what is the difference between the largest and smallest possible areas of the rectangles? So yeah, first of all, we know that we shall first let x to be the length and y to be the width of the rectangles. They told us the perimeter is 502, so 2 in brackets length plus width is equal to 202. Divide both sides by 2, we'll come up with x plus y equal to 251. Then make y the subject, you come up with y equal to this. So we can now come up with the possible dimensions of the different rectangles. And these are the dimensions. Length, width are given by this formula, x and 250 minus x. Now the possible values of x, or the possible values of the length, are from 1 up to 125. Now why is it so? It is because this one, that is 251, when I divide by 2, Using a calculator, I get 125.5. So there's 125, 1 and 126. So if I use 125, x is 125, it means this width will be 126. But if I put here 126, I realize that here this width will be 125, which is a repetition of the same rectangle. Yet they told us the rectangles must be distinct. So that is the reason why I stopped at 125. So if you are to list them, these are the possible dimensions. Here it means there are more dimensions in between. I think by now you know how to count the number of rectangles, or like the way we used to count number of pages. Would say this minus this, everything plus 1. So this minus that is 124 plus 1 to give you 125. So there are 125 possible rectangles. So that is the reason I've been talking about. Now they told us to get the difference between the largest and the smallest. Largest area is got from the largest dimensions, which is that. And the smallest area is got from the smallest dimension, 1 times that, which is that. Then the difference between the two you subtract, and that would be the answer they wanted. Then question 2, if all people eat the same amount of pizza, and a pizza 16 inches in diameter serves 2 people, how many inches in diameter should each of the 2 pizzas be in order to serve 3 people? And assume that pizzas are circular and are eaten entirely. So one pizza with this diameter was serving 2 people. But now they want 2 pizzas to serve 3 people, and they're asking what should be the diameter of those 2 pizzas. So we shall start by saying pizza eaten by 2 people has this area because they said circular. So use the area of a circle, which is pi d squared over 4, to give you 64 pi. Then pizza eaten by 1 person, you divide by 2 because these are 2. So to get for 1 person, you divide by 2 to get 32 pi. Then pizza eaten by 3 people, it means we're going to multiply this by 3 to give you 96 pi. Then we shall let d inches be the diameter of each of the 2 pizzas eaten by the 3 people. Therefore, the area of those 2 pizzas will be, this is because there are 2 pizzas, this is the area for each pizza. And the total area must be equal to this, which is eaten by 3 people. So I'll come and simplify this with this, you remain with the 2, which is here. Then this pi and this pi can go, and this can go this side to come up with d squared equal to 192. Then put square root on both sides to come up with 8 root 3 as the diameter, or you can use it round off to this. Any of the 2 is okay. Question 3 says, circle B passes through the center of circle A and is a tangent to it. Okay. Circle C passes through the center of circle B and is a tangent to it. Okay. What fraction of the area of circle A inside circle B is inside circle B but outside circle C? So we shall need to make a sketch. We shall draw a big circle, which is circle A with this center. Then they say the circle B passes through this center but touches, or is a tangent. So we shall also draw it. And then realize something. If this is the diameter, it implies that this one, the diameter is half of the diameter of circle A. Same applies to the radius. Then also the circle C, also the same, meaning that if this is R, the radius of the small circle, then radius of circle B will be 2R, and radius of circle A will be 4R. Then we shall come and, this is what we have said, so we shall now come and say that the required area is equal to area of circle B minus area of circle C. But remember they talked about fraction, but let's first get area. So the area of circle B is given by this, area of circle C is given by this. You simplify to get 3 pi r squared. Then the total area of circle A is given by this, which is 16 pi r squared. Therefore, the fraction they want will be this required area over the total area of circle A, which is 3 over 16. Question 4. The lengths of the sides of an acute angled triangle are successive integers. Show that the altitude of the second longest side divides it into two segments whose difference is in length equals 4. So this is a little funny, but we need to make a sketch. So let the lengths be this, because they said successive means consecutive. This followed by this, followed by this. So we shall label the sides. This will be the altitude. So the second longest side is x. If you look at this, because this is shortest, second longest, and longest. So here they talked about second longest, which is this. And they said the altitude to the second longest. That is why we have drawn from A to this, because they said altitude to the second longest. So you drop a perpendicular to divide BC. Divides it into two segments. So it will divide BC into two segments whose difference in length equals 4. So the difference they mean is that, for example, if you say BD minus DC, you must get 4. So basically that's what they want you to prove. So altitude has a height of that. Then BC is x, BD, if BD is y, it implies that DC is x minus y. Okay. Now the question is, if you subtract these two, do you get a difference of 4? That's what they want you to prove. So let's start. For triangle ABD, using Pythagoras theory, we come up with this. Expand this to come up with that. Make x squared the subject. Also, for this triangle ADC, use Pythagoras theorem still, expand, collect like terms, and make h the subject. Now both are equal to x squared, meaning we can equate the two equations. So when you equate the two equations, we shall come up with something. You realize that y cancels, y squared cancels, x remains, this also remains, but when this comes here, it becomes 4x. And here remain with this. Then this one and this one cancels. Divide throughout by x to come up with this. So x is equal to 2y minus 4. Okay. Now we shall come and say that required difference is BD minus DC. So BD was y, this is x minus y. Open brackets will come up with 2y minus x. But we know that x is this. So come and substitute for x. You realize that this and this cancels, remain with 4, and that's what they wanted. Question 5. The radius of each small circle is as 1/6 of the radius of the large surrounding circle. The radius of the middle-sized circle is twice that of either small circle. What fraction of the area of the large circle lies outside the 3 circles? So first shall let R to be the radius of the largest circle, meaning that area of the largest circle is this. Then radius of each small circle is 1/6 of this, meaning that area of each small circle will be that. Then they told us that the radius of this one is twice this. So come and get twice that radius. You come up with 1/3r. Therefore, area of that middle-sized circle is that. Now, when you subtract, okay, the area of the 3 interior circles will be, now here we said 2 times this because there are 2 small circles plus this to give you that. Then the difference fraction, required fraction, will be equal to remaining area over area of the largest circle. Remaining area is got by that over the largest circle, and you end up with 5/6. So now I'll leave you with assignment 4. So that brings us to the end of this video. Thank you for watching, and bear in mind the next video will be on solutions to assignment 4. Hello viewers, Wagadaruna taking you through this tutorial for O-level math contest practice. In this video, I'm going to go through the solutions to week 3 math contest assignment 4 for the year 2023. So this assignment is entirely under geometry. So question 1 says, what is the ratio of the area of a circle to the area of an inscribed square? So there we need to make a sketch. First draw a circle with center O, then we inscribe a square inside the circle. And let the square have sides x. The diagonal of that square will pass through the center of the circle. Meaning from here, T is the radius of the circle, which is R. Do you know something? We have got a right-angled triangle where the hypotenuse is 2r. So for triangle ABC, it implies that the hypotenuse is equal to this squared plus this squared. So open this bracket, this power is on 2 to the power 2 is 4, r at power 2 is r squared. Divide both sides by 2, you come up with this. Then That means that now I can get the ratio. So area of the circle is pi r squared. What about for the square? For the square is x squared, but you have already known that x squared is equal to 2r squared. So that will be the area of the inscribed square. Now we can get the ratio. The ratio will be, remember the order matters. They said the first began with area of a circle to area of the inscribed square. So area of the circle first, followed by the area of the inscribed square. So r squared can cancel to remain with pi to 2. If you stop here, it is okay, but some students can choose to go ahead and replace pi with 22/7. It is still okay, so that you reduce to get this. Then question 2 says a square ABCD has sides of length 3 centimeters. Side AB is extended through B to E with BE equal to 1 centimeter. Segment DE intersects BC at point F. What is the area of triangle CDF? So the first thing to do is to make a sketch of the square ABCD with sides 3 centimeters. Then they said side AB extended through B to E is extended through B to E. So we shall elongate it to meet point E. And they said BE is 1 centimeter. Then from there they said segment DE intersects BC at point F. So you have to draw a straight line from D to E. And they said meets BC at F, which is there. Then they said, what is the area of triangle CDF? CDF. Okay. So by similarity, BF over BE will be equal to 3 over 4 because these triangles are similar, which gives this, but we know that BE is 1, so come and substitute for BE, which is 1, you'll end up with BF as 3 over 4 centimeters. So I've got BF, meaning, remember my aim is to get this area. So if I have BF and I have AD, the balance will be CF. Therefore, CF will be 3 minus 3 over 4, which is 9 over 4. And now that I have CF and this DC, I can now get the area, which is a half base times height, which will be 27 over 8. Then question 3 says, in a rectangle ABCD, AB is 5 centimeters, BC is 3 centimeters. Points F and G are on CD with DF equal to 1 centimeter and CG equal to 2 centimeters. The lines AF and BG intersect at E. What is the area of triangle AEB? So we're going to first come and make a sketch of the rectangle ABCD. They told us BC is 3, which is the same as this, and also AB is 5. Then they said points F and G are on CD. But what is the condition? DF is 1 centimeter. So from point D we shall measure 1 centimeter and locate point F. Then they said CG is 2 centimeters. So from C we shall measure 2 centimeters and locate point G. The balance will be 2 because the total should be 5. Then they said lines AF and BG intersect at E. So we shall draw a straight line through AF and also through BG to intersect at E. Okay, then I said, what is the area of triangle AEB? Area of triangle, we need height and base. Now we know the base of the triangle, but we don't know the height. So I'm going to first draw a vertical line to meet a B. So this will be the height of this triangle. But on this height, we only know HK, because from here to here is 3 centimeters. But what about from here to here? That is what we need to first get. So still we have similar triangles. Meaning I can get now similarity. It means FG over AB is equal to EK over EH. And we know that FG is 2, then AB is 5, EK is X, and EH is X plus 3. Now we'll cross multiply and then collect like terms and get the value of X. After getting the value of X, it means I can now get the area of triangle AEB, because now the height will be X plus 3, which is 2 plus 3 to give you 5. Then the area will be a half base times height, which is 12.5. Then question 4 says the sum of the lengths of the 3 sides of a right-angled triangle is 56. Okay. The sum of the squares of the lengths of the 3 sides of the same right-angled triangle is 1250. Okay. Then what is the area of the triangle? So let us first make a sketch of this right-angled triangle and let the sides be A, B, C. So they told us the sum of all the lengths is 56, meaning A plus B plus C must give me 56. Okay. Then they said the sum of the squares of the lengths of the 3 sides of the same rectangle triangle is 1250. So I'll now square each length. This squared plus this squared plus this squared gives you that. Okay, these are 2 equations, but we have 3 unknowns, meaning for you to solve simultaneously, you will need 3 equations. Now the third equation will come from Pythagoras theory, where this squared plus this squared is equal to this squared. Now we can easily solve. So substituting equation 3 into equation 2, remember here you have a squared plus b squared, and also you have a squared plus b squared. So I can substitute and come up with c squared plus c squared equal to 1250. Add correct like terms, you get this, divide both sides by 2, then put square root on both sides, you'll be able to get the value of c as 25. Now I've got the value of c, but remember they want the area of the triangle, and to get the area you need this and this. So what can I do? I'll say that from equation 1, substitute for c, you'll be able to get this and take this for this side to come up with a plus b equal to 31. Now I have this one, I also have this one. What can I do? So I'll come and say that if I square both sides, this squared and this squared, what will happen? When we expand, we shall get something funny. This squared plus twice the product of the entry of both entries, then plus this squared. Now, why have I chosen to square both sides? It is because this plus this is c squared. So I can come and substitute for this and this, which is here. Collect like terms, take this on this side, you come up with this. Divide both sides by 2, you come up with that. Now, A and B are needed in our formula for area. Therefore, just come and say that area is a half AB, where AB is this. So substitute, you come up with the area they wanted. I think you realize that simultaneous equations, there's no way you can run away from them in math contest questions. Then question 5, in the diagram below, which is this, ABC is equilateral triangle, whose base AB is the diameter of the circle with AB equal to 12 centimeters. AC and BC intersect the circle at points P and Q, respectively, here and here. Find the area of the shaded region. So they want the area of this. To get this area, we shall need to first get something. So we're going to first come and say, for a equilateral triangle, interior angles are 60 degrees each. Okay. So let O be the center of the circle. So you come and put O here. Now because AB is the diameter, it means 6 will be here, 12 will be divided into 2, so 6 is here and 6 is there. So let's put them there. And I also said, then because all these ones are radius, OB, OA, OB, OP, and OQ are all radii. So it means that everything will be 6, 6. Okay, if this is 6 and this is 6, it means now so far these two angles should be the same. And also here 6, 6, meaning these two angles should be the same. So shall come and put there 60 also. Okay, then for interior angle sum, to add up to 180, the remaining angle here should be 60 and here 60. Now that means that this is an equilateral triangle where this side will also be 6 and this will also be 6. Okay, then also they told us AB is, okay, ABC is equilateral, meaning if this side is 12, this side should also be 12 and this should be 12. So when I already have 6 here, it means the balance will be 6 here, and also I already have 6, meaning the balance here is 6. So I'll come and put them there. Then here, angles on a straight line add up to 180. So if I have 60, 60, the remaining angle to make 180 will be 60. Okay, so now we can begin. Area of triangle ABC. I'm going to first get area of the whole of this triangle. It will be a half. Now this formula, I think we saw it in the training which happened in the second term holiday, whereby if a triangle has an angle and two sides enclosing that angle, you can easily get the its area. So if I choose an angle, let me choose this 60, the enclosing sides are this, and they are each equal to 12. So 12 sine 60. Sine 60 is a particular angle which is √3/2. So I'll come up with 36 √3 as the area of triangle ABC. Then for triangle AOP, I choose this angle, then the enclosing sides are 6, 6. So a half times 6 times 6, sine 60. Sine 60 is the particular angle, which is this, so we'll end up with 9 √3. Now this triangle and this triangle are similar, or they are equal. So what you're going to do, it means that even area of triangle BOQ is equal to 9 √3. So let's conclude that here. Okay. What about area of the minor sector OP2? Let's just see the sector OP2. Minor sector is this. There's this angle and the radius is 6, so it means this angle over 360, which is 60 over 360, times area of the circle, which is pi r squared. So that is where this came from. So you can end up with 6 pi. Then the area of the shaded part, it means that if I remember, we got A1, which is area of the whole of this triangle. Okay. Now, I'm going to first remove A2. If I remove A2, A2 is this. I've removed it. I'll also remove A3, which is this. I'll also remove A4, which is this. What I'll be left with will be the area of the shaded part. So that is why you see this expression, that A1 minus, in brackets, A2, A3, A4. So come and substitute A1, A2, A3, A4. Then you can open brackets to come up with this. So here it means this and this is 18 root 3, which is here. And this gives you minus 6 pi. Again, correct like terms, this with this, it gives you positive 18 minus 6 pi. So it is okay to stop here, but if you want, you can proceed and say pi is 22 over 7. So substitute for pi, you'll end up with this as the answer. So any of these two answers is okay. So that was the solution for the previous assignment. Now I'll leave you with assignment 5. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on solutions to assignment 5. Hello viewers, Wagadarana taking you through the story for O-level math contest practice. And this video I'm going to go through the solutions to week 3 math contest assignment 5 for the year 2023. So this assignment is entirely on geometry. So question 1 is a little wordy and tricky. So it says, suppose a circle is inscribed in a square, each of whose sides is 1 unit, okay, in length. Let A1 be the area of the circle minus the area of the square minus the area of the circle. Okay, next, a second circle is inscribed inside the first circle, and a second circle sorry, a second square is inscribed inside the first circle, and a second square is inscribed inside the second square. Okay, so you first draw the square of 1 unit, you inscribe it, then again you draw another square inside the circle, and again you inscribe that square. That's what they mean. Let A2 be the area of the second square minus the area of the second circle. Then the third circle is inscribed inside the second, then the third square is inscribed inside the second circle, and the third circle inside the third square. Let A3 be the area of the third square minus the area of the third circle. If this process is repeated until A10 is found, what is the value of A1 plus A2 plus S3 plus A4 plus A5? Leave pi in your answer. So here we shall need some diagram. So we shall need a relatively bigger square because we are going to do multiple inscribing. So let x1 be the side length of the side of that square. We already know from the question that x1 is equal to 1, but I've just put a variable for you to get the pattern. So this is now B1, C1, D1. I'm not labeled A, B, C, D because A is used in the question. So if I use it here, it will confuse us. That's why I've chosen to start from B, C, D, E. Now 1, 1 means the first square. If I put 2, 2, 2, it means the second square. 3, 3, 3 means the third square, like that. So I'll inscribe a circle inside. To inscribe it means I'll bisect this square and also get this diagonal. There I'll be able, this intersection is the center of the circle. So I'll draw the circle like that. Then I'll again inscribe a square inside this circle. I've called it B2, C2, D2, E2. Then another circle. Again, the process is repeated for the third time to get B3, C3, D3, E3. And then the third circle. Okay. So let's begin with the first stage. The first one is only this first square and the first circle. There we know that this length x1 is 1 unit from the question given. And we also know that this square has a radius which is half the length of the side of the square. From here to here is the radius which is half of x1. Therefore, I'll get the areas of this area of the square and area of the circle and subtract the 2. That is the area of the circle. Then when I subtract the 2, I'll be able to get a 1. And that is the value of a 1. What about A2? For A2, we shall need to get, now this is the square, and this is the circle of interest. So when it comes to the square, you realize something. From here to here is the radius of this circle, and it is also half the diagonal of the square. So meaning that B2 D2 is equal to 2R, where R is this radius here. So let's start by Pythagoras theory, where B2 C2 plus C2 D2 squared is equal to B2 D2 squared. So I've used x2 to denote the length of the side of the second square, and now this is the diagonal of that square. Remember we said it is R 2r. That's why there is 2r1. The good thing, we know the value of r1, it was a half. So I'll come and substitute. But before I substitute, let me first get the pattern between x and r. Put square root on both sides, you'll get that. So this will be the pattern. If I want to get x3, I'll use r2. If I want to get x4, I'll use r3, like that. So now that I know the pattern, I can get now the actual side I want. R1 is a half times root 2 to give you this. And R2 is half, because when you get this and you inscribe, the radius of that circle is half the side, length of the side. That's why you say half, to give you that. When I know side and the radius, I can get the areas. So A2 will be the difference between the two areas. Area of the side of the square is this times this squared. Area of the circle, pi r squared. You end up with this. I factorized out because this one is somehow similar. If you look at it, it is somehow similar to this. So there's a common factor. There's a common factor, and to help us get the relationship between the areas, the A2, A1, A2, A3, and F4 until the end. What about the third time? For the third time, I'm going to repeat the same process. We now know the logic that if I want to get x3, I'll use r2 times root 2. So r2, I already got it in the second stage, so I'll substitute r2 times root 2 to give you a half. And after getting x, I can get r by dividing by 2. So r3 is a half x3, which gives you a quarter. And on the other side and the radius, I can get a 3. So here I put an equal sign, but it should be a minus. So you put a minus here. So this gives you this minus this. So in the end, when I factorize out a quarter, I'll still get this. Now that we can identify the pattern. The first part, it was just 1 times 1 minus pi over 4. Second time, it was a half times this. Now it is a quarter times that. Do you know what it means? It means that they keep on multiplying from one term to the other. They keep on multiplying by a half. That implies that F4 is a half of this, which is this, and F5 is a half of this, which is this. Now that I have A1, A2, A3, A4, A5, I can get the sum which they wanted. And that will be the answer they wanted. Then question 2, triangle PQR has PQ equal to 13, PR equal to 15, and the altitude, which is the height, to side QR has length 12. Find all possible lengths of side QR. So you're going to first make a sketch. So there are two possible ways of drawing such a triangle. One is when the height bisects QR. Like that. Another option is when the height is drawn by extending QR. So you shall extend QR to come up with the height, which is 12. So there are two possible ways of getting, but in both cases, these values will be the same. This x is the same as this x, and this y is the same as this y. So one value of QR is got by saying x plus y. Another value of QR is got by saying y minus x. As simple as that. So for triangle PQT, any of the two you use is okay. So PQT, I can choose to use that, or I can choose to use this. I'll still get the same answer. Applying the Pythagoras theory, x will be equal to this squared minus this squared to give you 5 in the end. Then from triangle PRT, still use Pythagoras theory, y is equal to this squared minus this squared, put a square root, you come up with 9. Therefore, QR can be got by saying x plus y or y minus x. So come and substitute for x and y, you'll get the two values of QR which they wanted. Then question 3 says a circle passes through two adjacent sides of a square and its tangent to the opposite side of the square. If the side length of the square is 2, what is the radius of the circle? So here we still need to make a sketch. We have a square and we have a circle. So it is the tangent here and passes through the two vertices. Let R be the radius of the circle with center O. So you come and draw and locate center O and the radius. So if I join from here to here, it is still the radius. Also from here to here, it is still the radius. So those points will help us to get what we want. Remember, the side is 2, meaning this is half the square, so it will be 1, 1. Now, remember, AB is 2. From here to here is 2, but from here to here is R, meaning this balance will be 2 minus R. And when I have those, I can use now Pythagoras theory, where this squared is equal to this squared plus this squared. Expand, then this and this will cancel, and this will give you 5 to come up with 0 equal to 5 minus 4R. Then make R the subject to get 5 over 4, and that is the radius they wanted. Question 4. If a circle of radius A over 2 is inscribed in a square of side A, what is the radius of this? What is the radius of a circle Q that can be inscribed in a corner of the square tangent tangent to two sides of the square and to the circle inscribed in the square? The good thing they have drawn it for us here. Now they want the radius of this circle. So what we are going to do, we shall let O be the center of this big circle, and this radius was given as A over 2. So we shall come and divide and locate the center. This is the radius. So shall let R to be the radius of the small circle. So you put here the radius R. Now from touching circles, I think we covered touching circles, we saw that the distance between the centers of two touching circles is equal to the sum of their radius. From here to here is the radius of the small circle, from here to here is the radius of the big circle. So I know that the radius of this big circle is A over 2 and the radius of the small circle is R, meaning that OQ is equal to A over 2 plus R. Okay, so now that I know this, I can get this remaining part, which is QA from Pythagoras theory. So QA will be this, which gives you R root 2. And OA, if you go back to the diagram, O from O to A can be got from, because this from here to here is A over 2, from here to here is A over 2. So I'll use Pythagoras to get OA. Which is A over 2 root 2. But I know that OA is equal to OQ plus QA. So I have OA, I have OQ, I have QA. And my work is to substitute. So when I substitute, I have R, which they want. So I'll have to look for who making it the subject. Therefore, take this side. You'll come up with this. Here, factorize out a over 2, you come up with this. Factorize out r, you come up with this. Then divide both sides by this to come up with this part. So now remember I can't leave a surd in the denominator, so I'll have to rationalize, then expand, simplify, then put these two up, negative up to come up with this, and that's the value they wanted. Then question 5, in the figure below, AB is equal to SC and BAD is 30. AE is equal to AD. Find the value of angle EDC. So let's first label some angles which may help us to get the angle they want. So shall begin with this 30 which was given. Then here we can call this angle A, small a. Here this B we can call it angle small b. But because they told us they are equal, AB is equal to SC, is an isosceles. Then we can come here and we call it D. Then we come here and call it E. Okay, so remember they want us to get the value of D. The easiest is to use exterior angle property, whereby for triangle DEC, this will be equal to this 2. Put everything on one side to get equation 1. Then for triangle ABD, this 2 will be equal to this. Put everything on one side. Then I can solve them simultaneously. When I subtract equation 1 minus equation 2, this is what I'm going to come up with. So this minus this cancels, here we come up with 2D, and here we'll come up with positive 30. Therefore, D is equal to 15, implying that the angle they want is 15 degrees. So that brings us to the end of this video and to the end of the 3 woods training which you have been on. If there is any other training, it will now be for a level. So thank you for watching and thank you for being part of this training. I hope you have benefited a lot. And I encourage you to keep on practicing so that you can excel in the national math contest which will happen in April in the